Welcome to 5 Minutes with Errol Musk. I'm Anneke, clinical psychologist. Welcome, Errol.
Thank you.
Errol, you spoke the other day about first principles. How does it apply to children?
Well, it does apply to children. It applies to, particularly children, and it applies to anyone who's faced with a new task that they haven't done before, or some possibly machine-like device, even a car that they don't know much about, and they have had problems and needed to solve those problems so that perhaps the thing didn't happen to them again. And so it was not me that came up with the idea of working from first principles. I think I've even seen Einstein say that if you want to understand something, make it simple. Look for the simplest possible way of understanding something. And essentially, he was saying, work from first principles. So when someone asks you how, let's assume it's a child, how a motor car engine works, now that's quite difficult. So you would start off with the idea of explaining to them that previously there were no engines, there were horses. And can you imagine how a horse pulled a car or a cart, which may have looked a bit like a car but without an engine? And they will almost undoubtedly say yes, they can see that the horse is pulling the cart. Then I would say to them, well, so from a first principles point of view, you need something else now to drive the car. And so what is that? And you might tell them that it took humanity a long time to figure out how to make a device that can put out more power than is required to power it. And it was only in the late 1900s that the first engines were made, single cylinder by, I believe, Carl Benz. Now, how did he do it? He also worked from first principles. He presumed that seeing as this new substance that had been found to separate into different parts, which was oil, that if you take the thinnest part of that oil, it burns quite easily. In fact, very quickly. And he, one way or another, came up with the idea, maybe he saw his mother's pot on the stove boiling and saw the pot lid coming off from the steam, and he realized, and of course there had been steam engines that had already established the idea, but nevertheless, you're trying to explain a car engine to, say, a child, you would say that this man then worked out that if he burns this thin portion of the oil in a closed space, it would expand, and as it expands, it would. And you might say to the child, you notice that little drop of fuel, that you might show the child how big a flame it made. And then he might say yes, and you'd say, well, okay, you see that it expanded. So then you would say, so now if you did the same thing in a closed space, that would also expand. And so, like his mother's pot on the stove, it would push the lid off, or in this case, it would push a piston down. And you would explain to the child that how he found this could be repeated over and over and over. If you kept putting the drop of fuel in with an eyedropper or something, until eventually he found a way of putting it all together, and then later on found that he had a machine that if you kept putting these drops of fuel in, just kept turning and turning and turning, and it put out far more power you might say to the child, then he could even stop the turning with his hand. And so he realized that he could put this onto perhaps a vehicle and turn the wheels with it. So it would replace the horse. So now you have somehow gone back into sort of first principles. I mean, there are many other ways of approaching first principles. I mean, there's first principles in just about everything. People tend to overcomplicate things. Take the first principle of a man or a boy wanting, a youth wanting a girlfriend. You can take it down to first principles. I mean, you can, instead of trying to complicate the issue and try to see why some or other thing is not working, take it back down to the bottom, to what are you actually trying to do here? What are you actually aiming at? And if you understand that what you're actually aiming at is what it's about, then you start with the very basic way of achieving that. Now, as an engineer, I, for example, had a question the other day from finally a chemical engineering student who was struggling with the sizing of a cooling device that cooled liquid. And he was showing me all these tables and graphs and so forth to size this particular cooling device for this particular factory, which he wanted to cool oil from river water. So the way you would do it, you'd have an outer canister that contains the river water which you pass through, and you have an inner canister or inner sealed tube which lets the oil go through, and as the oil goes through, it cools, the water cools the oil. And he was working with these tables, and I said to him, listen, you must go back. 100 years ago, there were no tables. These tables have all been put together just empirically. In other words, people have, by experience, put these tables together. The tables themselves are not a magic solution. They were put together by people from experience. So initially, one would look at the amount of oil, let's say, that you want to cool, and you might decide to build a cooling device which is as big as a double-decker bus. But then you would see, well, you don't have a big enough space to do that. And if you have a very small space, you'll think, well, I'll build a very small one. But your head will tell you, no, this is going to be too small. So inevitably, you would build something that's probably too big right in the beginning, and you would have to limit the amount of river water that goes through, I explained to him, so that you don't overcool the oil. But these tables simply allow you to come to a more accurate sizing for efficiency. But it's all built on people having initially done these things by first principles, based on first principles. I want to cool this, and I've got this cool thing, like water, and I've got this hot thing, and I want to cool them. How do I do it? How do I cool a hot glass of tea or coffee? I put it into some cold water in a pot. That's the first principle, and you start from that.
Now, even I understand.
Yes.
Thank you, Errol.